Did you know that your brain works overtime when reading code? In 2020, a study by MIT revealed that understanding code relies heavily on the brain's multiple demand system, a network responsible for high-level problem-solving, logical reasoning, and executive functions. But here's the catch. Poorly written or unclear code can make your brain work way harder than it should. By writing clean, simple, readable, and well-structured code, you reduce mental overhead and you allow your brain to focus on problem solving rather than deciphering text. Here are some clean code principles that would make your brain understand the code faster. Let's have a look at this code. We can observe we have a lot of nested code. According to Miller's law, the human brain can hold 7 items in short-term memory. Keeping in mind the logic for each nested state while trying to understand the current state overflows our brain's capacity, making it harder with each layer of nested code. So we can simplify the code by just inverting the if statements, following the fail-fast principle. Check for what breaks the logic first, and exit early. So instead of verifying if O is not null, we can invert and verify if it is null, and if so, we stop the method there. This already looks more readable, but we're not done yet. Right away, it's clear there is no consistent naming convention. We've got snake case, random cap case, and cryptic single-letter variables. Can you instantly tell what O or B represents? If you cannot answer immediately, that's the problem. Studies show that consistent formatting and meaningful variable names help your brain focus on the logic instead of deciphering the text. So let's fix it. First, we change the names into something meaningful. But consistent code styles create mental shortcuts, speeding up comprehension. So we remove the snake case and the random cap case, and use only camel case. It's like labeling your storage boxes. You don't have to open each one to know what's inside. We are almost there, but if your code is one giant blob, your brain struggles to process it. Because of how our brain handles complex code, research on cognitive load shows that smaller, focused tasks are easier to understand. So our next step is to break our code into smaller, reusable methods. We can spot that the first 2 if statements both validate the order, so we can extract this into a separate method. And since they both throw the same exception, we can even combine them to make our code even more readable. Next, let's make the code even more modular by extracting into a method the process of buying an item. Now the code is modular and readable. Small focused methods reduce cognitive load, making it easier for your brain to understand the big picture without drowning in details. Let's look at another example. Here are 2 methods. One calculates the total discount and the other applies the tax rate. At first glance, they seem fine, but on closer look, there's duplicate code. Duplicate code forces the brain to track the same logic in multiple places, increasing mental effort and reducing focus. Let's imagine that we have to change the way we calculate those rates. Changes in one instance of the code may require updates elsewhere, forcing our memory to keep track of all duplicates. The code clone analysis research shows that cloned code increases the surface area for bugs and inconsistencies, and is significantly more error-prone. This is the reason why we need to remove the duplicate code and apply the dry principle. To fix it, we extract the duplicated logic into a single reusable method, and we use that method wherever needed. Avoiding duplicated code makes the project more maintainable and reliable. Going further, we reach this over-commented code. Cognitive science shows that too much text creates cognitive noise, distracting developers from the actual code. In our case, the cognitive noise is to the roof. Many developers over-comment, explaining what the code does instead of why. Good comments explain intent, not mechanics. We do not need a comment to initialize a variable. We do not need a comment for looping an array or list. And the code is self-explanatory for the total price formula. Also, we can see from the method's name what it does. The code is self-explanatory, so we should comment only edge cases or non-obvious logic to clarify those parts. Comments should complement your code, not distract you from it. Let your code tell the story wherever possible. Now let's move to our next example. Now imagine a method that processes an order, saves it into the database, and renders it on the UI. It's doing too much, and your brain pays the price. If we need to make changes in the user interface rendering code, our brain has to keep in mind all the steps that happened before. And we already know from Miller's law that our short-term memory can hold 7 items. This creates a dependency between functionalities, and just like the nested code we've checked before, it overflows our brain's capacity. So to make this code more readable, we need to separate the concerns into distinct sections and write classes or functions that have a single responsibility. Let's see how this works. Our business logic is in the service, our database logic in the repository, and our user interface rendering is in the view. If we want to make changes in the user interface with this code, it will affect only the view service. As a best practice, every class or function should have just one reason to change. So the next time you code, think of this. Is this name clear? Is this function simple? Am I repeating myself without reason?